students. Myself, Shaila Shitkar, Assistant Professor in Botany from Government College of Arts, Science and Commerce, Sakli. The name of the program is Bachelor of Science First Year. The subject is Botany, Generic Elective. The semester is 1, paper code is BOG 101 and the paper title is Environmental Biotechnology. The title of the unit is Microbiology of Wastewater Treatment and the name of the module is Treatment Schemes for Wastewater of Antibiotic Industry. Module number is 19. These are the outlines of the module. In this module, we are going to learn about the wastewater of antibiotic industry, physical, chemical and biological methods for wastewater treatment of antibiotic industry. These are the learning outcomes of the module. At the end of the module, you will be able to explain physical, chemical and biological methods of wastewater treatment scheme of antibiotic industry, and also you will be able to cite the differences between physical, chemical and biological methods of wastewater treatment scheme of antibiotic industry. Now coming to the introduction of antibiotic. Antibiotic is a type of antimicrobial substance that inhibit the growth of microorganism. It is a type of antibacterial agent that fight against bacterial infection in the living organism. This antibiotic is used in various fields such as human healthcare, agriculture, animal husbandry as antibacterial medicine. During the production of this antibiotic, lot of wastewater is generated by antibiotic industry that may contain organic and inorganic substances that has become a major aspect of environmental pollution. Why there is a need to treat the wastewater of antibiotic industry? The wastewater generated from antibiotic industry when released into the water bodies, it can lead to several effects such as death of fish or other marine creatures due to the accumulation of chemicals. The next is feminization in fish, meaning the chemicals in wastewater act as a female estrogen in male fish, which causes the male fish to produce small testes. In that, they produce female yolk protein found in the eggs. It also causes disruption of human endocrine system if we consume the water. Now let us learn about the sources of wastewater of antibiotic industry. The wastewater from antibiotic industry is generated by cleaning of reaction vessels, leakages, accidental spills, chemical waste, condenser waste, and floor and laboratory washing waste. Now let us see which are the pollutants present in the wastewater of antibiotic industry. Pollutants present in wastewater of antibiotic industry are solvents, active antibiotic ingredients, detergents, catalysts, volatile organic compounds, and cyanide. These pollutants in the wastewater of from the antibiotic industry can cause a serious environmental threat if discharged without any treatment. Now let us learn about the wastewater treatment scheme of antibiotic industry. The wastewater treatment scheme of antibiotic industry consists of three methods: physical methods, chemical methods, and biological method. Physical methods are the physical removal of suspended solid. Chemical method is the chemical treatment given to the wastewater, and the biological method is the degradation of organic matter by microorganism. Physical method consists of multimedia filtration, polishing pond, incineration, condensers, scrubbers, adsorption, and steam stripping. Chemical methods consist of alkaline chlorination treatment, hydrogen peroxide treatment, hydrolysis treatment, and ozonation. Whereas biological methods consist of trickling filter, activated sludge process, and a flow anaerobic sludge blanket reactor, that is UASBR. Now let us learn about the physical methods of antibiotic industry wastewater treatment scheme. The first is multimedia filtration. Here, the effluents are filtered by introducing the wastewater into a filter bed. The filter bed is composed of sand, diatomaceous earth, and granular media. The next is the polishing ponds. Polishing ponds is also called as lagooning, which removes the remaining suspended particles after the secondary effluent treatment. It is around 5 to 10 feet deep. The storage duration is 1 to 3 days. So in this polishing pond, the water is kept in a open pond in a natural condition with an full exposure to a open air. Here, the aquatic plants, weed-eating plant, invertebrates are also introduced into the polishing ponds to absorb or to consume any particulates present in the polishing ponds. The next is the incineration. It is used to remove the organic compounds from the wastewater. It is a process of burning of waste at a high temperature in the absence of air. Here, the effluents are removed by introducing in a fixed bed. The effluents are burned by combustion and remaining water vapor is discharged into the atmosphere. The next is the condensers. It removes the organic compounds from a gas stream. The gases containing the organic compounds are cooled below to their saturation temperature, converting the gas into the organic liquid. The next method is scrubber. Scrubbers are also called as a gas absorbers, which removes the organic pollutants from a gas stream by treating it with liquids such as water or acid onto the gas. The next method is adsorption. Here, the effluents are removed by passing through a filter media. Filter media is composed of activated carbon, silicates, and aluminosilicates. The next method is steam stripping, which removes the organic pollutants from the wastewater by passing a steam to a tray or packed column. During the process, the steam is injected at the bottom of the tower to provide heat and vapor flow. Combined effect of heat and vapor converts the organic material from liquid to a vapor phase. Now let us learn about the chemical methods of antibiotic industry wastewater treatment scheme. The first is alkaline chlorination. It is the process which involves the addition of hypochlorite or mixture of chlorine gas and sodium hydroxide to a cyanide bearing wastewater. In the first phase, the cyanide will oxidize to cyanate, and in the second phase, the cyanate will oxidize to nitrogen and carbon dioxide. The next method is hydrogen peroxide treatment. The process involves the addition of hydrogen peroxide to a cyanide bearing wastewater, which will convert the cyanide to ammonia and carbonate ions. The next method is hydrolysis treatment. The treatment involves the addition of sodium hydroxide to a cyanide bearing wastewater, which will convert the cyanide to formate and ammonia. The next method is ozonation. It is the process which involves the infusion of ozone into the water. Ozone is considered as an effective oxidant which will help to oxidize the organic pollutants present in the wastewater. During the process, the ozone is produced by subjecting the oxygen to high electric voltage or to UV radiation. Now let us learn about the biological methods of antibiotic industry wastewater treatment scheme. The first is a flow anaerobic sludge blanket reactor, which is also called as UASBR. which is an anaerobic process where anaerobic microorganism will convert the organic pollutants into a biogas. The next is the trickling filter, which is an aerobic process which involves absorption and oxidation of organic matter into a sludge when it passes through the filter media. The next method is activated sludge. It is a process by which the effluents from the wastewater are degraded by microorganisms which will convert the effluent into sludge. These are the references of my module. Thank you.